Howdy guys. So today we're going to be looking at ionic compounds and covalent compounds. And the main question we're going to ask ourselves today is, what are different physical properties that I can look at to tell the difference between ionic and covalent compounds? Now you guys have kind of looked at some of these different and similar physical properties in your lab already. But today we're going to really take a deeper look into what makes an ionic compound, and a covalent compound, a covalent compound. So let's take a look. Okay, so this first main difference in an ionic and a covalent compound is an ionic compound is a bond between a metal and a non-metal. Now, what do we mean by metal and non-metal? Well, when we're looking at the periodic table, we are looking at anything below these stair steps that I've highlighted. So anything below these highlighted elements are metals. So anything in this middle block, and we're mainly looking at these two groups over here. So sodium, magnesium, potassium, calcium, things over here. Non-metals are things above these stair steps, these highlighted elements. So nitrogen, oxygen, fluorine, chlorine. So a bond between sodium and chlorine is going to be an ionic bond. That's going to be an ionic compound because it's a bond between a metal and a non-metal. A bond between carbon and oxygen is going to be a covalent bond. That's going to make a covalent compound. It's a bond between two non-metals. That's one of the big differences in these. But when we're looking at a solution or when we're looking at a compound, we really don't know what's in these compounds. So we have to test them. And one way we can test these is an ionic compound. It's a high melting point and a high boiling point. They have strong bonds, so it's harder to break them. So when we're looking at something and it goes up to 700 degrees Celsius to boil, that's going to be an ionic bond because that's a really high temperature. In contrast, covalent bonds and covalent compounds have low melting points and low boiling points. These bonds are a little bit weaker than ionic bonds, and so it's going to take a lot less energy to break them. So like water. Water is a covalent compound between hydrogen and oxygen. And it goes up to 100 degrees Celsius to boil. That's a lot lower than, say, 700 degrees Celsius. Another difference is ionic compounds, they're all soluble in water. So when we drop an ionic compound, like salt, or like table salt, which is sodium and chlorine, that's going to dissolve in water, always. Now, with covalent compounds, they're a little bit different. This is where we divide them into two categories. So we call them nonpolar and polar. Nonpolar, this is how it sticks in my head. Nonpolar is not soluble in water. Polar is soluble in water. So just remember, nonpolar, not, and polar is. And so if I told you that we had a compound that when we drop it in water, it doesn't dissolve, we automatically know we have a nonpolar compound. But if I told you we had a compound that when we drop it in water, it did dissolve, well, we don't have enough information yet if it's polar or not polar covalent compound or an ionic compound. The next big difference, ionic compounds, when you drop them in a solution and dissolve them, they're going to be conductive. And you guys have already kind of seen this in your lab already, but when we say conductive, we mean it will conduct electricity and let electricity move through it. Covalent bonds and covalent compounds, when they dissolve in water, they're not going to let electricity move through them. They're not going to be conductive. Now, these two compounds do have some similarity. Number one, they're both not conductive as a solid. So if they're not dissolved in a solution, they're not going to be conductive. Two, they both contain nonmetals. Remember, an ionic compound is a bond between a metal and a nonmetal, contains a nonmetal. Covalent has two nonmetals bonded together. So they both contain nonmetals. We're going to take a deeper look into what makes an ionic and covalent compound themselves. But for now, we just want to be able to distinguish between these two compounds by looking at their physical properties. So That's the way the cookie crumbles.